Hello friends, now let us take up the concept number 6.8, recursion. In some programming situations, a method, in order to achieve its task, it calls by itself. A method calls by itself. That means, in order to achieve the task of a method requires its own services. From a real life angle, illustratively, a catering contractor is there. A catering contractor provides catering services to the public. Suppose if he is having a function, if he is organizing a function in his home, he never engages some other catering contractor. He takes his own services in order to complete the job. In the same manner, sometimes in some programming situations, program may demand a method in order to achieve its task to take its own services. This case normally explained by a common example, calculating factorial. Actually, in this connection, I will tell you one thing. In interviews or in examinations, sometimes it may be difficult for you to explain a concept technically. In such case, if you depend on an example or illustration, job will be easy. The technical concept you may not explain satisfactorily, even though you can give the illustration or example very easily, or otherwise you can give a programming example that is much better. So in this context, whenever you have to explain recursion and all that, the common example is calculating factorial. Now let us see. This is factorial of 5. 5's factorial. How we write? 5 into 4 into 3 into 2 into 1. Now, if I write 4's factorial, this one, if I call as 4's factorial, I think you don't have any objection. What is 4's factorial? 4, 3, 2 and 1. Then this I can rewrite as 3's factorial. Okay, then what does it mean? 3 into 2 into 1. Now this can be written as a 2's factorial. This can be written 2 into 1's factorial. Now in this context, one more point I have to explain. Actually, a method is calling by itself continuously, indefinitely. When it is stopped, actually it is subject to a condition. Whenever a condition is satisfied or an event occurs and all that, the calling, recursive calling is stopped. Then whatever task you are expecting from the method can achieve it. So here in this case you see 5's factorial, 5 into 4 into 3 into 2 into 1. You can call this as 4's factorial, you can call it as 3's factorial, you can call it as 2's factorial. Like that. Now every time in order to calculate that, you want this one. In order to calculate this, you want this one. In order to calculate this, you want this one. That means if you want factorial for n, you require the factorial of n minus 1. N minus 1 you require, n minus 2 you require. How long it is continued? In this case, up to it comes 1. 1's factorial is required. 1's factorial is 1. So in this case, how long this recursion is made, how long the factorial method calls by itself until it requires the factorial of 1. Okay, but it's not an indefinite one. Understand? Now let us see it in a program. Program demo. This is demo 6.3. Here factorial we are calling. This we name as a factorial test or factorial calculation. And here you see one static method we are calling. We made factorial as static. The basic reason is we are not going to create any objects. Here I want to demonstrate the recursive method. Here I don't want to create objects and don't want to complicate the issue. First you have to understand this mechanism. That's why I am using one static method. Static method means no objects are to be created. Before that only we can use that. So public static long. Actually sometimes you should not go by simple arithmetic and all that. You have to apply your common sense. Now when you are calculating factorial and all that, the result is enormously increased. 1 into 2, 2, 2 into 3, 6, 6 into 4, 24, 24 into 5, 120, 100 into 20 into 6, 720. Like that, the result grows like anything. So simply if you put int, it may not satisfy. It may not hold that number. Of course, int is so big. C, C++, if you take 2 bytes, int range is very small. But Java's int is so big because it is 4 bytes. That's why if you put int also, there is no, because it take 2 billion. So here if you put int also, nothing wrong. As a precautionary measure, I put as a long. Now what code I have written? If n is less than or equal to 1, return 1, and else return n factorial n minus 1. Factorial n minus 1, already I showed you. 5 if you want, 5 into factorial 4. 4 if you want, 4 into factorial 3. When want factorial 3, 3 into factorial 2. So that is n factorial n minus 1. This is nothing but calling the method by itself. This is the method body, you know that. Within the method body, which method is being called? The same method is calling, self-calling. This is called recursion. Now in this only we are writing main also a static method, and now you see int n, and now through command line argument you are entering a value, an integer value you are entering, and you are parsing it, and in turn this is calculated. Now suppose you have given 5 into factorial 4, next 4 into factorial 3, like that it is calculated. Whenever it becomes 1, return 1, and recursion is stopped. It is returned. Return means from calling method, the control goes to the caller. So there will be no more recursions. Then it is stopped. Ultimately, you can get the result of the program. So you must remember what is a recursion. Recursion means a method called by itself until a condition is satisfied.